All right, welcome. Today we're diving into the story of a true unsung hero. We're talking about an invisible force that's all around us, powering literally everything we do, from the quiet rhythm of your own heartbeat to the intense roar of a massive bonfire. So, who is this mysterious hero?
So, what do you think? What is this stuff? You're actually using it right this very second, but you can't see it, you can't touch it, you can't taste it. And yet, if it suddenly disappeared, life as we know it would just, poof, gone.
You guessed it, it's oxygen, the star of our show today. Now, it might sound like a pretty simple topic, but trust me, this element has some absolutely incredible superpowers that we're about to get into. Okay, first things first. Let's crack open the official file on our hero. Because to really get what oxygen does, you first got to understand what it is.
So at its very core, oxygen is an element. You can think of elements as kind of like the universe's Lego bricks. They're the most basic building blocks of everything. Oxygen is a non-metal, and you'll find it hanging out over on the right side of the periodic table. Simple enough, right?
But here's the thing about oxygen. It's not a loner. It's actually super reactive, which means it loves to connect with other atoms. And when you get two or more atoms bonded together like that, you've got yourself a molecule. And that's exactly why the oxygen we breathe isn't just O, it's O2. See that little 2? That's super important. It means it's a molecule made of two oxygen atoms that are joined together, like they're holding hands and not letting go. That's the stable version of oxygen that's floating all around us. So if it's all around us, why aren't we wading through puddles of it? Well, it's because at any normal temperature, oxygen is a gas. Its little molecules are just zipping around freely in the air. But why a gas? Now this is where it gets kind of mind-blowing. We all know water boils at 100 degrees Celsius, right? That's when it turns into a gas. Now look at oxygen. It boils at minus 183 degrees Celsius. That's insanely cold. So at any temperature that we would consider even remotely normal, oxygen is way, way, way past its boiling point. That's why it's a gas. Okay, so we've met our hero. Now for the good stuff. Let's talk about its first major superpower, powering life itself. And it does this through a process called respiration. Respiration is just the fancy science word for how our bodies turn food into actual energy. It's this tiny chemical reaction that's happening right now inside every single one of your cells. It's where oxygen meets up with glucose, the sugar from your food, and together they unlock its energy. And how does it get where it needs to go? It's this awesome four-step journey. First, you breathe in. Oxygen floods your lungs. Second, it zips right through the walls of your lungs and hops into your bloodstream. Third, your blood acts like this super efficient delivery service, rushing that oxygen out to every single cell in your body. And finally, the grand finale. Oxygen finds the glucose, and bam, energy is released. That's literally what's powering you right now.
So when you boil it all down, it's really that simple. Respiration equals energy. It's like a tiny, slow, perfectly controlled fire happening inside all your cells all the time, just to keep the lights on. Every single breath you take is feeding that process.
And the flip side of that is pretty stark, right? No oxygen means no respiration, and no respiration means no energy. It's the one non-negotiable ingredient for pretty much all complex life on our planet. But hang on, powering life is only half the story. Oxygen has this other superpower, one that's a whole lot faster, a whole lot more dramatic, and, well, a bit more explosive. We're talking about fire. So the technical term for burning is combustion. Now, just look at that definition for a second. A substance reacts with oxygen and transfers energy. Sound familiar? It should. It's basically the exact same idea as respiration, but happening at warp speed. Instead of a slow, controlled release inside a cell, it's a rapid, blazing release of heat and light out in the open. And we see this all over the place. A cozy campfire? That's combustion. A car engine turning gasoline into power? That's a chain of tiny, controlled combustion events. Basically, anytime you see a flame, you can bet our hero, oxygen, is right there in the middle of the action. But hold on, if all you need is fuel and oxygen, why isn't the world just constantly on fire? Well, there's a crucial third ingredient you need to get the party started. You need heat. You need that initial spark. A log can sit in a fireplace surrounded by oxygen for years and do nothing. It's not until you add that heat from a match that the reaction kicks off. So let's kind of zoom out and tie this all together now. We've got oxygen, this one element, playing two totally different roles. On one hand, it's the quiet sustainer of life.
On the other, it's the wild fuel for fire. It's the same exact stuff, but doing two essential yet opposite jobs. It's incredible when you think about it. And this breaks it down perfectly. You've got respiration here, that's the slow, steady release of energy that keeps us going. And then you've got combustion, the fast, intense, explosive version we use for heat and power. It's the same process, just with the speed turned way, way up. So if you remember just one thing, make it this. Oxygen is the ultimate keymaster. It doesn't have the energy itself, but it holds the key that unlocks the energy stored in everything else, whether that's the sugar in your cells or the wood in a fire. Oxygen is what turns that potential into power we can actually use.
And that just leaves us with one final thought to chew on. If one single invisible gas is the key to both the quiet miracle of life and the awesome power of fire, what does that say about all the other incredible, untapped energy that's just hidden in the everyday stuff all around us, just waiting for the right key? Something to think about. Thanks for joining me.